Hi everybody, welcome to Unit 2 Video 6. If you have not watched Unit 2 Video 5, please watch that video first and then watch this one. And also make sure you have out your Show Me What You Can Do notes. If you don't, please go get them now. All right, so it says, I can identify if a relation is a function and find its domain and range. So remember, we talked about if something is a function, for every x input, there can only be the one y output. And the domain represents all of our x values, and the range represents all of our y values. So when we look at this, we have our x values and our y value, our x and our y. So if we notice, when we put in 1, they got out 2. But when they put in 1, they got out a 3. 1, a 4, 1, a 5, and 1, a 6, which means no, this is not a function. So I'm going to write on here, not a function. So not a function. All right, so we can still name the domain because remember the domain are all of your x values. So I'm going to put them in this bracket. And if you notice, since the x value repeats of 1, I'm just going to put a 1 here. And you only have to write it one time. All right, my range are my y values. So you usually want to go in order from least to greatest. So I have 2, 3, 4, 5, and 6. So that's my range of values. Okay, so now let's take a look at number 2. So again, for every x value, we can only get out the one y value. So when they plug in 0, they get out a -1. When you plug in 1, you get out a 2. -1, a -1. -2, 5, and 2, 9. So it works. So it is a function. All right, so I can write the domain. So the domain are all my x values. So I have -2, -1, 0, 1, and 2. And my range or my y values, I have -1, 2, 5, and 9. All right, I want you to go ahead and pause the video and see if you can do numbers 3 through 6. All right, so let's go ahead and see how you did. So number 3, it is a function. So here's my domain and then my range. Number 4, it's not a function. So the domain is I and n, and the range is m, p, q, t. All right, for number 5, it follows the rules of being a function. So here's the domain and range. And number 6, not a function, because remember, 1/2 and 0.5 are the same. And so when you plugged in your x value, you got 2 different y values, so not a function. All right, but remember there was another way to identify if something was a function, and that was by doing the vertical line test. So for these next set of problems, you want to go ahead and see if it passes the vertical line test. And the vertical line test said if you draw a vertical line, it can only go through your shape one time, through one coordinate. But this doesn't. It hits here and it hits here. So this would not pass the vertical line test. So we say it's not a function. Function. All right, again, you want to draw your vertical lines and see if 8 and 9 would pass the vertical line test. So this one, if you were to draw a vertical line, your line would only hit one coordinate each time. So it is a function. And the last one, does it pass the vertical line test? No, it does not. So it'd be not a function. All right, so let's go to the next type of problems. It says, in each relation, x and y are integers. Find the domain of the relation and draw its graph. Is the relation a function? Okay, so first we have to figure out what the domain is. Then, once we figure out the domain, we can figure out our coordinate pairs, and then we can sketch a graph of what the relation would look like. So x and y are coordinates, and they're saying this is the rule. The absolute value of x equals the absolute value of y, and the absolute value of x is less than or equal to 1. So we've got to decide what could x be? Well, it has to follow this. It has to be the absolute value of x is less than or equal to 1. So I'm going to start here with my domain. And I say, okay, well, the first number that would come to mind would be numbers that are less than 1, less than or equal to 1. But I can't choose like -3. That's less than or equal to 1, except that when I put it in the absolute value, I would get a positive. So if I put a -3 in here and I took out the absolute value, I'd get 3. And 3 isn't less than or equal to 1. So the first number that I can come up with is -1 for x. So if x equals -1, if I were to simplify it and take the absolute value, I'd get 1 is less than or equal to 1, which would be a true statement. So my first domain is going to be x. X equals -1. So let's write this coordinate. If I plug in here -1 into this equation, -1 for x, I have to say, okay, the absolute value of -1 equals the absolute value of y. So you have to think to yourself, well, what are the possible values that y would be if I plug in a -1 for x? Well, if I plug in a -1 for x and I took the absolute value, I would get out a +1. So you have to think about what could y be, so that if I took the absolute value, I'd also get a +1. Well, your choices would be -1, because when you simplify this, the absolute value of -1 and the absolute value of -1, 1 would equal 1. Now, I could also plug in -1 for x here. I'd simplify it and I can get a +1, but I also could plug in for y a +1. So I would get, so when I plug in -1, I can either get out for y a -1 or a +1. Okay, so now I have to think, all right, what else could x be according to my rule here? Well, the absolute value of x is less than or equal to 0. I could plug in 0, because if I simplified it, 0 is less than or equal to 1. So I'm going to plug in 0. So if I plug in 0 for x here, then I have to say, okay, the absolute value of 0 is equal to the absolute value of y, which means y could also be 0. All right, so then I have to say, are there any other numbers that I can plug in for x? Well, yeah, I can plug in a +1. So if I plug in a +1, the absolute value of 1 would be 1, and that is less than or equal to 1. So x could be a +1. So if I plug in a +1 for x, then I have to figure out what I could get for y. So I know if I simplify the absolute value of 1, I would get 1. And since this is absolute value, it means y could be a -1. Or if I plug in a 1 for x, y could be a +1. So here's all of my coordinate pairs. Oops, I forgot to write 1 in my domain. Okay, so here's my domain, and here's all of my coordinate pairs. Now, just by looking at it, you probably could tell if it's a function or not a function, but we're going to go ahead and do a little rough sketch here of this graph. So let's say we had 1, 2, 1, 2, 1, 2. So I'm just doing a little quick coordinate plane. And let's say I graphed this point. -1, -1 would be right here. If I graphed -1, +1 would go right there. 0, 0 would be here. And I'd have 1, -1, and 1, 1. And so if I were to do the vertical line test, this relation would not pass the vertical line test. So we would write not a function. All right, let's go to the next one. Again, we're trying to figure out our domain, we're trying to figure out our coordinate pairs, and then we're gonna sketch the graph and decide, is it a function or not? So again, we have to look at our rule here. X is less than or equal to 3, but there's some restrictions on this rule. The absolute value of y is equal to x. Okay, so we have to think about, all right, well, x has to be less than or equal to 3. So you have to think, what numbers are less than or equal to 3? Well, let's try -3. -3 is less than or equal to 3. But if I plug in -3 here for this x, this says the absolute value of y equals x. If I take a number out of absolute value, can it be negative? No, it has to be positive. When you take out the absolute value, you'd have to get a positive. So this means here, this x cannot be any negative number. So that means my domain would have to start at 0. So if I plug in 0, so I'm going to say if I plug in 0 for x, then what could y be? Well, y would also have to be 0. All right, x is less than or equal to 3. I already tried 0. So the next number that's less than or equal to 3, I'm going to try is 1. So if x is 1 here, then I need to figure out what could y be. Well, if x is 1, y could be a negative 1, because when I take the absolute value of negative 1, I'd get out a positive 1. Or if I plugged in 1 for x, y could be a positive 1, because the absolute value of positive 1 is 1. All right, so back to my rule here, x is less than or equal to 3. I tried 0, I tried 1, so I can also try 2. 2 is less than or equal to 3. So now when I plug it in here, if x equals 2, then that means my two possible choices for y would be a negative 2, or if I plugged in 2 for x, I could also get out a positive 2. All right, it says x is less than or equal to 3. So I could also try 3 for x, because that would satisfy this. 3 is less than or equal to 3. So if I plug in 3 for x, then I have to say, what could y equal? Remember, since you're taking the absolute value, I could either have a negative 3, because the absolute value of negative 3 is 3, or if I plug in 3 for x, I could get out a positive 3 for y. All right, so here's all my coordinate pairs. And again, probably by looking at them, you can tell if it's a function or not, but we're just going to do a quick sketch. So you want to just sketch a coordinate plane. And this one went to by 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so then I'm going to go ahead and plot my coordinate pairs. So I had 0, 0 right here. Then I had 1, negative 1. I had 1, positive 1. I had 2, negative 2. I had 2, positive 2. And I had 3, negative 3, and 3, positive 3. So again, if you were to do the vertical line test, this would not pass the vertical line test. So you could say not a function. All right. So I want you to look at number 12 here. And so now you're saying, okay, we have to find the domain. So what are the possible values for x? What are the possible values for y? And together, the absolute value has to equal 2. All right, so I want you to pause the video and try to do number 12. Okay, so let's see how you did. So here was our possible domain. So like if I plugged in negative 2 for x, and then I'd have to plug in a 0 for y, because when I simplify this, the absolute value of negative 2 would be 2, and 2 plus 0 would equal 2. I could also plug in a negative 1 for both of them, because when I simplify that, I would get 1 plus 1, which would equal 2. So then here are the rest of the numbers I got for my domain. And so when I graphed it, again, it would not pass the vertical line test. So again, this one is not a function. All right, so when you're ready, I want you to pause the video and try number 13. Okay, so let's take a look. So our restriction here was the absolute value of y is less than or equal to 2. And remember, since this is absolute value, if you put a negative number in here, when you take it out of the absolute value, it becomes a positive number. So my domain was here. Okay, so I have to go ahead and look at the coordinate pairs that I got. When I plugged in negative 2 for x, I got a positive 2 for y. So when I simplified that, I would get 0. So the absolute value of 0 gave me 0. And when I plug in 2 here, the absolute value of 2 is 2. So it satisfied both of my rules. Okay, so then when I plotted my points, I got something that looks like this. And in this case, it would pass the vertical line test. So this is a function. So you can write function. Okay, all right, let's go to the next page. Okay, so the next one says I can evaluate a function at given values. So now this is our function notation. So this is saying f of x equals 5x plus 2. And they said for find each function for f of 7 and f of negative 1/2, which means now we just need to plug 7 in where we see our x, and we're going to simplify. So we're going to do two separate ones, f of 7 and then f of negative 1/2. So first I'm going to start with f of 7. So over here I'm going to plug in f of 7 equals 5 times 7 plus 2. So f of 7, oops, I'm sorry, this is 5 times 7 plus 2. There shouldn't be a parentheses around them. 7 plus 2. So then when I simplify here, I'm going to get 35 plus 2. So I get f of 7 equals 37. So remember, it's just saying f is a function of x. So when you plug in 7 for x, you'll get out 37. So it'd be your y or your y value, your coordinate. Okay, so then I'm going to try the next one. So this is f of negative 1/2. So when I do f of negative 1/2 equals 5 times negative 1/2 plus 2. Okay, so now I can say f of negative 1/2 is equal to negative 5 over 2. And remember, this is over 1. So if I wanted to make the common denominator, I'd multiply 2 to the top and the bottom. So this is plus 4 over 2. That's a 2. And so then f of negative 1/2 equals negative 1/2. Because negative 5 over 2 plus 4 over 2 is negative 1/2. And then let me just fix this here. There we go. All right, so there's our two answers when I found f of 7 and f of negative 1/2. So let's go ahead and try this next one. So we're doing f of 7 and f of negative 1/2. So the function is f of x equals negative 1 over 3x plus 1. So let's go ahead and plug in the 7 first. So we're going to do f of 7 equals negative 1/3 times 7 plus 1. So I have f of 7 equals negative 7/3. And again, it's plus 1, but I'm going to change it to common denominator, so 3 over 3. And then f of 7 would equal negative 4/3. All right, and I'm going to go ahead and box my answer. And the next one is going to be f of negative 1/2. So I'm going to plug in, f of negative 1/2 equals negative 1/3 times the negative 1/2 plus 1. So f of negative 1/2 equals negative 1 times negative 1 is a positive 1, and 3 times 2 is 6, plus, again, I'm going to make a common denominator, so 6 over 6, because that would simplify to 1. So then f of negative 1/2 equals 7/6. And you can go ahead and leave them as improper fractions. All right, so the next part here, we're saying, suppose f of x equals negative 3x plus 2 and g of x equals 1/2 x minus 1. Find each value. All right, so I want you to go ahead and pause the video and try number 15. Okay, so how did you do? So when you substitute in, hopefully we got f of 1/3 equals 1. All right, so let's go ahead. I'll help you set up this one, and then I want you to pause the video and solve it. So we're going to plug in g of negative 2 and f of 3. So g of negative 2, I'm going to write it this way, would be g of negative 2, so 1/2 times negative 2 minus 1. And so this is over f of 3, so f of 3. I'm going to put over, and f of 3, so the f function is negative 3 times 3 plus 2. Okay, so pause the video and finish simplifying. Okay, so let's see how you did. So when you finish simplifying, you should get a positive 2/7. So the way I wrote my final answer, oops, this is wrong. It should say g of 2, g of negative 2. Sorry, that's my fault. So g of negative 2 over f of 3 equals 2/7. All right, let's go ahead and look at number 17. So now this is what we have here is you read it as g of f of 3, okay? And this one would be f of g of 3. So the first thing you have to do is the innermost one. So we have to find f of 3 first, and then once we find that answer, we can plug it in and find g of whatever that answer is. So you want to do it in parts. You want to say f of 3 would equal, so we have to look at the f function first. F of 3 would equal to 5 times 3 minus 1. So f of 3 would equal 15 minus 1. So f of 3 would equal 14. All right, so now we simplified the f function. We can take this 14 here and plug it in for g because f of 3 is going to give us 14. So that's going to look like this. I'm going to do it over here. Now you're going to say g of 14, and you're going to plug this into the g function, equals 2 plus 14 squared. So we have g of 14 would equal 2 plus 196. And so then when we simplified that, we would get 198. So we write it as one function. So we say g of f of 3 equals 198. All right, so now this is different. This is f of g of 3. So now you have to do the g function first, then get that answer and plug it into the f function. So I want you to pause the video and try that. Okay, so let's go ahead and take a look at how you did. So we should have gotten f of g of 3 equals 54. So when you did the g function first, you got 11. Then when you plugged it in to the f function, you should get out 54. So f of g of 3 is 54. So remember, when you're doing something like this, you do the innermost one first. All right, let's go ahead and take a look at our last one. And now they're doing the same thing, except instead of numbers, they have a quantity, a variable here, and a variable here, a quantity here. So we're going to plug it all in. So same rule applies. We're going to plug all this in where we see our x. So h of x equals 1 minus 2x. So that's going to turn into this. 1 minus 2 times a plus 1. And then when we say minus h of a, so minus 1 minus 2a, because we have to plug it into the whole function. Because it's h of x equals 1 minus 2x. Now, the part that you have to be careful with, this whole thing, 1 minus 2a. So you brought down the minus sign. This is in its invisible implied parentheses. It's a quantity. And so just like this one has the parentheses, we need to distribute this -2, and we need to distribute this negative here. So we're going to get 1 minus 2a, minus 2a minus 2. And this is going to give us -1 plus 2a. All right, so now we need to combine our like terms and simplify. Well, this -2a and this positive 2a would cancel. This positive 1 and this -1 would cancel. So I'm left with just -2. And so the way that you can write this is you would say h of a plus 1 minus h of a equals -2. All right, so here's your answer. All right, everybody, thank you for watching the video.